good afternoon and welcome everyone to our first webinar of 2024. My name is David Godwin and I'm the director of the Southern Fire Exchange program with the University of Florida. I'm joined today by Elliot Nauert with our program through NC State University. Today we're excited to feature our researchers Dr. Ray Crandall and Dr. Jen Phil from the University of Florida and land manager Chris Kinslow from the St. Johns River Water Management District. Together, they will be sharing presentations on wiregrass restoration and management. I'd like to take a quick moment to share a little information about the Southern Fire Exchange if you're not familiar with our program. We are a regional program for fire science delivery in the Southeast. We are a collaborative among the University of Florida, Tall Timbers Research Station, and NC State University. We're sponsored by the federally funded Joint Fire Science Program, and we are the southeastern branch of the nationwide Fire Science Exchange Network. We work with our network of partners to develop programs, opportunities, and events like this one that seek to bridge the divide between the fire science and natural resource management communities. If you're joining today from an area outside of the southeastern US, we're glad you're here. Thanks for joining us. And if you're not already connected with your local Fire Science Exchange network, you can go to firescience.gov, find a map that looks like that, and connect with your Fire Science Exchange in your neck of the woods. And I hope you will try to do that. And finally, we are hosting a special Wiregrass Fireside Chat next week on Thursday, February 1st. So next Thursday, February 1st at 12 p.m. Eastern, at noon Eastern. And this will be an open Zoom meeting where you can connect with a small group of like-minded fire managers and researchers who are also working on wiregrass issues. So just like a field workshop, fireside chats are designed to be unscripted, unrecorded, low-stress environment where you can get your answers to your questions. You can share your challenges, share what you've figured out with wiregrass restoration, and help build your network. Our speakers today will be on that fireside chat. So if you want to continue the conversation, to have more back and forth with them, all you have to do is sign up. So we'll have the login and link to get connected with that next Thursday. So with that, we're going to go ahead and get things started. So our first speaker is going to be Chris Kinslow. But before I move on, I'd just like to say thanks, Chris, Ray, and Jen. We're excited to have you with us today. And just a moment, everybody, as we go ahead and get Chris Kinslow and his slides pulled up.
Good afternoon, everyone. My name is Chris Kinslow, and I'm a land resource planner with the St. Johns River Water Management District within its Bureau of Land Resources. I've been with the district in various capacities since 2014. And prior to working at the district, I was a land management specialist at Ordway Swisher Biological Station in Putnam County, Florida, for 6 years. So just to kind of go over some background. So some background on what the agency that I work for does. So the St. Johns River Water Management District is an environmental regulatory agency of the state of Florida, whose work is focused on ensuring long-term supply of drinking water and to protect and restore the health of water bodies in the district's 18 counties in the Northeast and East Central Florida. While the district works closely with utilities on water supply issues, we are not a water supplier itself. So in 1972, Florida's legislature created 5 regional water management districts in Florida, and through the passage of the Water Resource Act. We derive much of our revenue from property taxes, though we also generate revenue through timber sales as well as cattle leases. So if you live in Florida, you'll likely see some type of water management district on your property bill. The St. Johns River Water Management District has 4 core missions: water supply, water quality, flood protection, and natural systems management. The last mission is where our bureau falls into. Part of fulfilling the natural systems mission is the acquisition and management of conservation lands. The district owns more than 700,000 acres from Vero Beach to the Georgia border, and the agency manages 430,000 of those acres. And those are you can see the yellow polygons on the map on the left. Those are district managed properties. So between that 430 and the 700,000 acres, other agencies like Florida Fish and Wildlife Conservation Commission, Florida Forest Service, Florida Park Service manage districts held by, or lands held by the district on our behalf. So of those 430,000 acres, they are subsequently broken down into 6 management regions. And I was lucky enough to work in the West Land Management Region, which is pictured on the right-hand side of the slide. And I worked there for approximately 8 years. That region is centered around several conservation areas in Alachua County, totaling about 40,000 acres. So currently that region is being managed by Amy Copeland, Cal Madden, DJ Hill, and Jordan Warmke. And all of them are heavily involved in many facets of land management, including wiregrass planting and ecosystem enhancement. I actually stepped away from a burn to come that they're conducting right now on Longleaf Flatwoods Reserve. So they're out there getting it done very, very well, especially for people for 40,000 acres spread out between a pretty wide geographic region. You stay busy. So in addition, while I was there, Jeremy Olson was my supervisor during these projects that we're going to speak about today, and he was a huge support. So I want to make sure I acknowledge him too. So within the West region, there are several regional ecosystem restoration and enhancement projects that we've undertaken since 2015. The majority of them occurred on Lochloosa Wildlife Conservation Area, and you'll see these areas are on the right-hand map. Kind of the polygons on the right-hand map are where they took place. Some of it also occurred on Longleaf Flatwoods Reserve, which neighbors Lochloosa. That's a smaller site, and that's actually where Dr. Phil and Dr. Crandall in their lab has done research that we'll talk about here shortly. In total, approximately 70 acres have been planted in that time span. All the projects were a bit different as far as seeding rates and preparation methods, but they all involved enhancing the existing vegetation suite on sandhill sites that had been degraded due to past cultural practices involving pretty heavy mechanical site preparation when the properties were managed by a timber company prior to the district coming into ownership in 1996. We focused on wiregrass, but we made sure to include a variety of other seeds that often set at the same time as wiregrass, like blazing star or lopsided Indian grass. Some of the sites at Lochloosa Wildlife Conservation Area were planted in longleaf pine after they were seeded, while others were planted while other sites were planted with ground cover under recently thinned pine stands. The site at Longleaf Flatwoods Reserve was a clear cut of loblolly pine. It was not reforested with the intention of creating a wiregrass donor site as well as a research area. So I'd like to kind of go step by step into the common methods that we use at the district to collect and plant wiregrass. So let's start with collecting the seeds. This occurs in late November through early December in our area following a growing season fire. We have developed partnerships with other land management agencies in the region to allow district staff and equipment to collect on their land in exchange for fire staffing on prescribed fires or mechanical fuels treatments using district equipment and operators. We also collect off of district lands within the West region. This picture was taken at Longleaf Flatwoods Reserve, which has a very nice sandhill in its northwest corner. And recently, we've harvested off of Hatchet Creek tract of Noonan's Lake Conservation Area, which is by the Gainesville Regional Airport. So this piece of equipment shown is a front-mounted flailback or seed stripper. This unit is 4 feet wide and is driven by a hydraulic pump tied to a small motor. The pump turns a set of bristles on the drum and shakes the seeds off of the plant and deposits them in a large hopper. So here's a graphic from Ag Renewal, which is the company that makes the flail bag, that kind of shows a cut through of how that flow back works. So this concept works for a variety of seeds, both large and small. And it's not a new concept. My uncle grew up on a farm in North Dakota, and they used nearly an identical device to collect blue stem seeds. The difference was that there was a drum being pulled by a mule in a similar kind of fashion, and the nail head or the drum had nails instead of the nylon bristles that are commonly used now. So this is the same unit, kind of a different angle of it. And again, it's manufactured by Ag Renewal. It was previously mounted on an ATV, but it put a significant strain on the ATV, and not only the weight of the unit, but when you're collecting, you're going very slow. So that ATV overheated pretty consistently, whereas a tractor is kind of made to go pretty slow. So we've done pretty well using that same device but mounted on ATV. So the seed is collected internally, and then it's dropped out of this trap door that is held by a linchpin. And so it just drops out and the seed falls down. That's why you have the tarp on the trailer to kind of just motor up to that, drop it down, and then you can kind of go through it. So currently the manufacturer has wider versions at 6 feet and 12 feet that are tractor mounted and driven off of a PTO pump attached to the back of the tractor. So this is another style of seed stripper. It's a pull behind unit. The concept is exactly the same. It has a higher capacity than the front mount unit, but its maneuverability is much lower. Yeah, gotten jackknifed around trees pretty well. But its capacity, it's almost 2 to 1. So when you're considering going and sorting through everything, you get a lot more production rate, it feels like, off of the offset, this pull behind unit. This is an older unit made by Argyle Machinery, which is out of business. It's out of Canada. There is another company in, I believe, Nebraska called Gray Wind Industries, and they make a very similar unit. I believe Ordway Swisher has one from them, and it's a pretty nice piece of equipment. So this is what you get when you inside the hopper. So not only do you collect a lot of wiregrass seeds, but you get sticks, pine needles, and often green leaves. These are not ideal for a variety of reasons, from creating clogs in the drop seeder that we use to plant the seeds, to potentially introducing mold when those green leaves start decaying. Dr. Crandall will go into the storage practices in a little bit, but a good first step is to start sorting out all that big stuff in the field before you start bagging it and bringing it to the planting site or storage area. I don't have a picture of how we kind of store it or bag it, but generally we just use tall, long clipping bags, those kind of 10-gallon paper bags, and just fill them up about 2/3 full, so you have a little bit of air. You can fluff them up while they're still in the bag. And so it's not too compact, but it still breathes. It's not like a plastic bag. So here's a couple pictures showing some of what the sites look like prior to planting. The upper photos are of a clear-cut site, which had a significant windrows that were removed and then subsequently planted in those footprints of those windrows. So our planting area was essentially long linear strips. We used the soil from those windrows to build up some roads that we were having significant erosion issues on. So we took that opportunity to, while there was already disturbance scars, to kind of to replant those areas. The lower picture is a recently thinned pine site where we planted in the harvest rows, so the take rows in between. It was a 4th row thin, so we planted in those 4th rows. So we took advantage again of disturbance where that was created by the skidding of the harvested trees. Both sites had wiregrass on it, but they were not terribly abundant. The upper sites of the clear cut didn't have hardly any lopsided Indian grass. So, but there's always, you stop and see these little strips in between, say, a road right away and a fence line that kind of give you a glimpse of what it used to be. And there was plenty of lopsided in that little strip, but not so much actually on the site where all that where the site preparation took place. So after we collect the seeds, the next step is planting the seeds. So we use a grassland or drop seeder. They come in a variety of widths, from 4 feet to, I believe, 12 and even 16 feet. This is an 8-foot model. So you take the harvested seed and load it into hoppers, as you see Kyle doing there. Within these hoppers are tines that fluff the seeds and gears that grab the seeds and send them down a drop chute, which is essentially a PVC sewer pipe. You can see it highlighted there in the yellow oval. The seeds float down and are packed in by that bank of tires at the rear of the implement. We often disc the sites to get the seed bed prepared. We also used a landscape rake type implement on sites that have pine overstory, just to kind of scarify the soil, but not actually dig into the soil. Most of the techniques that we used are based off of the Florida Fish and Wildlife Conservation Commission's ground cover restoration implementation guidebook. And I believe we'll have a link to that document in the chat. It's really valuable. It goes through storage methods, harvesting or collecting methods, and particularly for the grasslander, it shows the gearbox setup. So the way that all those tines and gears are motivated is through a chain and cog system that's driven by those back tires, by the rolling of the back tires. It goes through that large black box. And when you get the grasslander, it can be set up for a variety of ways. So it comes with a whole bunch of different gears, but that documentation or that ground cover restoration implementation guidebook has a really nice step-by-step instruction on how to calibrate those gears for wiregrass planting. Though we usually plant between December and March, and a couple months later, you'll end up seeing sprouts. And so this is in July of after a February seeding. And all those little sprigs you see there are wiregrass. So and after that, it starts becoming a kind of a strange time for many restoration sites. They'll often look really weedy. We have seemed like a lot of knotweed would come up. But you got to get really good at IDing those plants, because many of them are just annuals that will drop out as the wiregrass becomes more robust. Our main competition in this area, because prior to it being commercial silviculture, was range. So there was still plenty of Bahia grass and Bermuda grass in a lot of these areas, and that seems to be a pretty big issue for us. Try your best if you have a similar site like this that does have Bermuda Bahia grass. Do a really good job on the forefront competition control, and then try with spot applications afterwards. We would end up just with a backpack walking these linear features and just hitting the tillers of the various grasses that were trying to creep in from the sides. Keep in mind, wiregrass is killed by glyphosate, so broadcast application after planting is not recommended. So in about 2 years, you'll get something like this. So a lot of the broader leaf grass is lopsided Indian grass, and all the more finer grass is wiregrass. And at some point between that last picture and this one is where I became acquainted with Dr. Phil and Dr. Crandall and their lab, and who are looking for some research sites. And luckily, what we were doing really fit with what they were looking to research. So it began a pretty fruitful relationship, and we're definitely glad to be part of it. So that I'll stop sharing.
I'm Ray Crandall, and I'm going to continue on from where Chris left off to tell you about the collaborative research between the St. Johns River Water Management District and us being myself, Jen, Phil, and many students. And I'll highlight some of the research as I talk. Before I begin, I also want to acknowledge many of the people on this call that have guided our research and answered our questions as we embarked on our own wiregrass restoration and management project. Without many of you, we would have been just stuck in decision paralysis and unsure of the next step to take in our restoration. So I've been working in fire a really long time, more than 20 years. I started in fire doing prescribed burns with the Nature Conservancy, and then moved out west to be a wildland firefighter for a couple of years. After that, I went back to school to get my master's and my PhD. And I like to say that I went from being a firefighter to an igniter, and not just an igniter of prescribed fires, I do that, but also an igniter of curiosity in our next generation of researchers and fire practitioners. I teach our forest fire ecology and management course at the University of Florida, and take students out and actually show them how to burn, and they get their S130-190 in my course. Jen got her start in fire as an undergraduate when she signed up for an S-130-190 class and discovered how much fun it was to burn in the woods. And from there, she dove into her graduate work on pine savanna fire ecology and restoration in South Carolina, where she first met wiregrass almost 15 years ago. Although she's bounced around the world a bit and even worked as a wildland firefighter, she's been involved with wiregrass research since her first encounter with the plant. And you can see that photo that's there in the center, Jen's bandaged feet. We are all probably familiar with that, the boot bite that you get when you're a firefighter. We're both really excited to share our results with you, and I'll be presenting, and Jen's actually going to be in the chat. She will answer your questions as they come in if she can. She'll also post some links and information as various topics come up during the talk. Now, I know many of you work in restoration and you're concerned in some way with managing southern forests. We all know that restoration and management can be really challenging and that there's a lot of uncertainty. We're really interested in my lab in this from the perspective of restoration and reducing the uncertainty in restoration. So what I'm showing you here is a diagram that came out of research done by Tyler Carney during his dissertation. He did a survey looking for challenges in restoration and divided them into various stages. So planning, site preparation, collecting and planting seeds, and early restoration. And he identified restoration activities associated with uncertainty during each of these stages. And we think of these stages as sort of moving from a more degraded to a more restored state. So I'm going to kind of use this as my outline today as I talk, focusing a lot on the collecting and planting of seeds, but I'm going to go through the whole process and some of the decisions that we made when we restored about 5 acres of land. So beginning with planning, you want to identify your reference site, determine your restoration goal or goals, and evaluate the restoration site to then move on to site preparation and determine what that site needs. Now, I'm not saying this is our reference site, but I'm sure many of us would love our restoration sites to look like this within our lifetime. This picture represents a dry sandhills pine savanna. The photo was taken at Ordway Swisher Biological Station. And you can see in the overstory, we have wide-spaced pines. They're relatively sparse. And then grasses are quite abundant in the understory. When we think about fuels moving through pine savannas, when we think about fires moving through pine savannas, we think about the fuels and where these fuels are coming from and how they're connected to each other. So in this system, we have the pine needles that are being dropped from trees. Then we have grasses. And all of these things create a continuity of fuel that help fires move across the landscape. One of the big components in this is wiregrass. Wiregrass is a bunch grass, and it has really thin, sort of wire-like leaves that dry out very quickly and ignite. And they also sort of grow up and flop over. And so one plant is often connected to another plant, which helps fire spread across the landscape. And sometimes wiregrass is also called 3-on. In the lower left-hand corner, you can see the 3-ons coming off of the lemma of the wiregrass, which is characteristic of this plant. Wiregrass helps maintain a fuel fire cycle. So if you think of an area once it burns, go out a week or two later, or even during the winter, and in our region, you typically see that wiregrass has started to regrow. Over time, fuels build up, including wiregrass and pine needles, and it makes the area conducive for the next fire. After the next fire, we see the cycle begin again with wiregrass regrowing and the fuels building up. So wiregrass is a component of this fuel fire cycle, and it's why wiregrass is often targeted along with other understory species in restoration. Now, I'm going to state quite explicitly in our restoration project that our goal was to develop an understory plant community that can carry fire. Our goal was not to increase biodiversity. Of course, that's something that we hope happens over time, and our objectives may shift over time. But in our initial restoration, our goal was an understory community that can carry fire. This objective lines up with the St. Johns River Water Management District. It is their goal in many of their restoration sites to also create that continuity of fuels and get fire to carry across the landscape. I'm going to talk mostly about a restoration site in north central Florida on St. Johns River Water Management District project or property. This is the Loch Lusa Wildlife Management Area, but I will also present research from Austin Carey Forest and Ordway Swisher Biological Station, which is just a little bit north of Loch Lusa Wildlife Management Area. This is also in the natural range of Aristida beyrichiana. I'm going to be clear that we did study Aristida beyrichiana, not Aristida stricta, which occurs further north. We can argue about taxonomy later, and that's fine. But I just wanted to give you some context as to where we are with this. This is an aerial photograph of the approximately 5 acres that we studied and started from a relatively degraded state. In pre-Columbian time, this site would have been a mixed upland hardwood and pine community or sandhill community. The community state likely would have depended on the fire regime. This site has sort of been through a lot. The earliest available imagery indicates the site was cleared of timber prior to 1937. There's also evidence of cultivation, including row crops, and also after the row crops, it transitioned to silviculture. Between 1999 and 2004, there was some thinning of the hardwoods with subsequent planting of pine trees in rows. And in 2018, pines were harvested and the site was mostly cleared except for a few live and southern red oak. And you can see those here. And this is what the site looked like prior to us coming on board. We came on the scene in 2021, seeking an area where we could test different restoration practices using wiregrass seed. So that sort of gave you a little bit of the introduction of the planning and sort of where we were going with our goals and objectives. And then we had to move on to site preparation. So thinking about what was there and then what would be necessary in terms of preparation to meet our goals. And of course, I should mention, although I'm not going to get into this a lot, it is important to balance site preparation and resources available. It would be great if we all had money for plugs or to buy clean seeds, but we know that that's very expensive. And so you have to work within your resources available. We did intensive site preparation. And this started in early September of 2021 when it was disked and herbicides were applied. Then roots were raked for some of the tree stumps that were still present. Then it was herbicided and it was disked again prior to seeds being planted in early March of 2022. Now, this is not always necessary. We started with a degraded system, and I should also mention that this was a research project, and so we needed consistent starting conditions across the field. Part of getting those sort of consistent starting conditions was to do this more intensive site preparation. We did have some patches of good intact ground cover. We left those, and the red oaks we left behind. So we do have some natural community plants that are going to flower and are going to disperse seeds into this restoration area. So it was not a complete clear. We left some of these little patches. Now, I mentioned that we should really understand what's present before we begin restoration, because we know, especially if wiregrass is our target, that wiregrass is really stable. It has very, very high survival. And we even found wiregrass populations can persist in long unburned sites. So I'm showing you here a site from Ordway Swisher Biological Station. It had not it had not been burned for more than 30 years. And an undergraduate in our lab, Cesar Zamora, observed that there was still wiregrass hiding under this thick layer of pine needles. And so once you start digging around, you saw that there were actually quite a few there, the yellow circles on the right photograph. So we were fortunate in that Ordway Swisher was able to burn this area, and we were pleasantly surprised that the plants survived. They regrew quickly after fire, and they actually produced good quality seed. So the seeds had a relatively high fill and a high germination. So the next step is selecting your seed source and the sowing density, evaluating seed quality, and measuring soil health. And I'm going to stay on this one for a little while because I really want to narrow in on the seeds. As many of you know, if you burn wiregrass, it flowers afterwards. And there are particular times during the year when wiregrass is more likely to produce good quality seeds that are able to germinate. A project that was done by Mary Nell Armstrong, a master's student in my lab, examined the production of seeds and the seed quality when you burn during different seasons. So when we examined sites that were burned in winter or January, we didn't find plants that were flowering. Not that they can't, we have seen some evidence that they can, but we did not see any in her study. If you burn during the spring or March, you see a high number of flowering stems or flowering culms that produce seeds. If you burn during the summer or June, you see fewer flowering culms, fewer seeds. Well, here's the thing. What we also found is that although more seeds are produced after those spring or March fires, fewer of them germinated. So overall, for a net positive, it was more beneficial from what we found to burn during the summer. That June month actually had a higher proportion of seeds that germinated. Now, can you look at seeds and determine whether or not they're going to germinate? No. Wiregrass is kind of known for producing a lot of empty seeds, and often those empty seeds look quite similar to filled seeds. There are several ways that you can figure out whether those seeds are filled. One of those is to send off your seeds to the USDA Forest Service National Seed Laboratory and pay a small fee to get x-rays of the seeds. You might be able to see on that photo that the sort of the brighter white lines, those are filled seeds, whereas the ones that are more of a gray, those are unfilled seeds. So even from this photo, you can see there's probably less than half filled seeds, not a ton. Now that costs a little bit of money, and this costs even less, if nothing. You can also do the enhanced forceps press test. So you take a pair of tweezers or forceps, you hold the seed about halfway down, and then you push the bottom of the seed away from the three awns. And if it bends really easily, then it's likely unfilled. But if it's kind of rigid and you're just pressing gently, you don't want to break the seed, then it's likely filled. If you want to see this, how this is actually done, we have a video that's posted on our Wiregrass blog, and I believe Jen is going to drop a link to that in the chat. So we have seeds, we consider the quality of those seeds, but we also need to think about where are we getting those seeds from? And we know that seed sourcing is an important aspect of the wiregrass seed market. One of the largest challenges is understanding how plant-environment relationships affect wiregrass establishment success. We have found some evidence in our research of ecotypes that they know their soil. And so it's beneficial to source seeds from an area near your site that has similar characteristics. And this is research that was led by Jessica Hong, a master's student in my lab. Well, our soils are quite variable. We had a soil survey done, and I'm showing you here the map of our 5 acres. And we used depth to the water table to delineate the soils into those that were wetter and those that were drier. The soils were mostly ultisols, with the lighter gray ones you see here being dry soils identified as millhopper, and the darker wet soils identified as spar. And I will go into more depth when we get to it as to what the little squares are, but for now, just look at the light and dark and the variation across this 5 acres. One of our interests was to see whether we sourced seeds from dry or wet areas, if that would have an effect on their establishment if we planted them in dry or wet areas. So we took dry seeds, planted them in dry areas, wet seeds, planted them in wet areas, and then dry and wet and wet and dry. Now, throughout this talk, if I say dry seeds or wet seeds, I'm referring to where we sourced them from, whether we sourced them from a dry site or from a wet site. In this case, the seeds were collected in early December. Seeds from the wet site were obtained from Hell-Scott Preserve, and then the dry seeds were collected from a site near Ikafina Creek Wildlife Management Area that had been planted with Ocala seeds. So I know someone might say, well, that's a little far from where you're doing this restoration. And it's because the seeds, the plants had been previously or recently planted from Ocala. So I will mention this in our study in wet and dry seeds, and then also across many areas, we see a lot of variation in wiregrass seed quality. And so what I'm showing you here across the x-axis are seeds from dry areas, seeds from wet areas, and then the burn date. So dry seeds from a site burned April 21st, or wet seeds from a site burned May 21. And then I'm showing you the percent of total that are either filled, damaged, infected, or empty. The filled seeds are likely to germinate. We find very high germination of seeds that are filled. It's hard to tell the difference between seeds that are filled and damaged. Sometimes seeds will be filled, but when you germinate them, the shoot elongates, but the root doesn't. So it is something to sort of be aware of, that there may be a small fraction of seeds that are actually damaged and don't quite have what I would say normal germination. Then there are seeds that are infected, and I'll talk about that in just a moment, and then also empty seeds. The infected and the empty seeds are unlikely to germinate. Infected seeds often have a smut on them, and the smut looks like a pickle. Don't be concerned if you see your wiregrass with some of these pickles. It's nature and it happens. It's not really much you can do about it. There are a lot of factors that affect the production of filled seeds. So we did a meta-analysis from a bunch of different sites, and we found overall there were some trends in when you burn. So if you burn in June versus May, you get an 18% increase in filled seeds. If you burn in June versus July, you also get an 8% increase. So there's some change over time, but I do want to stress it's also relatively site specific. We have one research site that's been burned every year since the 1970s, and in some years it produces all unfilled seeds. They're almost like dust. So there's likely interactions between frequency of burn, season of burn, and site conditions. There's also some evidence that precipitation also affects seed fill. So for each 10 millimeter increase in precipitation 2 months before a fire, the odds of seed fill actually increases by 1%. Not too much, but if we look at the precipitation during seed development, and this is after the fire, the odds of seed fill increases by 6%. Okay, so this is the months before the seed is mature. So in our field, we had this, I would say if we had decision paralysis, it was here. What seeding rates should we use? And we talked to a lot of you about what seeding rate, what have you used in your restoration projects? And we sort of settled on, we'd love to start with a 10 pounds per acre But I'll be honest, we didn't have enough seeds. So we sowed the entire field at just under that, about 6 pounds per acre. And then we increased in specific plots the amount of pounds per acre of seed to 10, 15, and 25. The field was planted with a grasslander, and it was planted in strips. And so the first strip to the left, those are the dry seeds, and then a strip of wet seeds, a strip of dry seeds, and then a strip of wet seeds again. And then within each of these, we've established plots in these separate areas to look at the 3 seeding rates and then also the effect of planting different seeds into different soils. In total, we had 196 plots spread over these little squares. Okay, so we planted and then we started monitoring. We haven't quite gotten to the point of managing competition, but let me tell you some of the results and what we're seeing with early establishment. Now, when I mentioned that we seeded this in early March, some of you who do wiregrass restoration might have cringed. You might have thought, oh my gosh, they got their seeds in the ground way too late. Our seeds came up April 1st, and boy, were we nervous. We were out there all the time looking for seeds, but there was an area adjacent to ours that had been planted by the St. Johns River Water Management District, and they planted theirs much earlier. So we kept looking at their site and looking at our site, and we wouldn't see seeds in theirs, and we wouldn't see seeds in ours, and we're like, okay, we're still okay. But as of April 1, they came up on their property and ours. And boy, were we really excited to see these little seedlings. So now I'm going to show you a graph. I'm going to walk you through it and show you the results. These are still really preliminary, but we wanted to know what sort of seedling density we were getting between the different seed types and soil types. Along the bottom, or the x-axis, is the seeding rate. And so you'll see the 10, 15, and 20 pounds per acre. And then along the side, or the y-axis, are the number of plants in each plot. And then the 4 different graphs just show you the wet seeds in wet soil, wet seeds in dry soil across the top. Those are the blue dots. And across the bottom, dry seeds in wet soil and dry seeds in dry soil. So the only thing that really mattered here were the seed types. There were far fewer plants per plot when we used the dry seeds, regardless of whether they were in the wet soil or they were in the dry soil. And there wasn't any variation, nothing that was significant between the different seeding rates. And so likely there's some minimum threshold, and we certainly hit it with the 10 pounds per acre, where increasing beyond that really didn't result in more plants per plot. And this is also a lot. Some of these plots have, almost 60 or over 60 plants in a plot. These plots are 1 meter by 2 meters, so they are not big. Some natural thinning is likely going to occur over time to get down to what we might find in some of our natural areas. So what accounted for the difference between the wet seeds and the dry seeds? Well, for the seeds that we used, we found that seed fill was 3 times greater in the wet seeds than the dry seeds. Now, I'm not saying that wet seeds are better than dry seeds. This is just what we found for our seeds. And it reflects the variation that we see in seeds and in seed quality. And it's not just between wet and dry areas, but it also has to do with site conditions, probably past fire regime, and that sort of stuff. So we're still trying to figure out really what affects seed quality, but I would say it's probably a lot of things. And this is really exciting. We had new seedlings in the second year. We had heard from a lot of people, get your wiregrass seed in the ground right away, and it's going to germinate that year, and that's it. Seed goes bad. It does not last. And we found new seedlings in the second year. So when we started sampling this year, we were really surprised to see new individuals. And this 5 acres is in an area where there isn't going to be a ton of seed that's being dispersed into the area. And so we know that it's seeds that we planted last year. Well, after we observed this, we started calling people, likely some of you on this webinar, and we said, did you know about this? And people said, yeah, I did a restoration project. Nothing came up in the first year, but I waited until the second year and I had a ton of germination. So we know that this is possible, and it was really exciting to see this. So just to wrap things up a bit, there is a lot of uncertainty in wiregrass restoration, and we certainly experienced a lot of that decision paralysis as we were going through, but we had a lot of great people in the wiregrass community, restoration community, give us some really valuable insights and advice from their observations. But I think despite this uncertainty, we can use what we know about seed quality to certainly help us decide things on, how much seed needs to be collected, or even if you want to collect from a particular site because maybe the seed fill is especially low, and start to make observations about what affects seed quality. So although our focus was really on wiregrass, many other species also established. And it's still kind of in the ugly duckling phase of restoration, lots of dog fennel and such, but a lot of flowering plants. And we've had a rich community of insects. So I would say we're on our way to success. But if you want to follow us on our restoration journey, go to ecologyonfire.com. From there, you can link to our Wiregrass blog, where we talk about the things that we learn over time. We share information that we gain from other restoration practitioners. And as we discover new things, we will post new blog posts. There's also a panel discussion February 1st at noon, and David mentioned this. I encourage you to sign up if you want to chat and discuss more about wiregrass. And for those of you who have done a lot of restoration, we'd also appreciate your insights. And I'm going to end there.
All right, Ray. Well, thank you so much. I'm going to go ahead and add spotlights to Jen and Chris. And thank you so much for your presentations. We have a great turnout today. We've already had some questions coming in the chat, in the Q&A tool in Zoom. And Jen and Chris have been hard at work addressing those questions. So we have some time saved at the end of our program today. I see some questions that are already starting to come in. Jen, do you want to take the lead on going through those questions and fielding some of those as they come in?
Sure. Yeah.
Chris and Ray, do you guys want to go ahead and chime in and address those while we have the time?
Okay, so I'm in the question and answer box here. I'll try to keep an eye on the chat as well. So first question we have from Todd St. John: does wiregrass have mycorrhizal associations that is needed for it to, assuming, establish as well? And yeah, that's an exciting question for us because our latest research project does show that mycorrhizae do influence wiregrass establishment. We're working on the publication, so that should be out eventually this year, hopefully. We planted wiregrass seeds in soil that we collected from a disturbed site, as well as soil from Ordway Swisher that had not, been disturbed. And additionally, in a mixture of disturbed soil and commercial mycorrhizal inoculum. And we followed their establishment over the next several months. And it turns out that wiregrass biomass was highest in the disturbed soils and lowest in the undisturbed soils. And we also had the mycorrhizae quantified in a collaborating lab at UF. And it turns out that there were a greater number of mycorrhizae spores in the disturbed soils. So there's some association going on there that seems to drive wiregrass biomass and establishment. So it's a great question. Thanks for that. We'll be sure to post in our blog when that paper comes out. Ray, do you have anything to add, or Chris?
Nope, that was great.
Yeah.
Okay, cool.
And a lot of these really nutrient poor sites like scrubs and sandhills usually have a pretty robust mycorrhizal fungi community. So there was a question in the comments about herbicide for hardwood control. Let's see, what type of herbicide do you use to control the broadleaves without affecting the pine or wiregrass? A lot of what we used for site prep was triclopyr or Garlon element. But the actual chemical name is triclopyr. And a lot of that was broadcast spray. Let's see. It was about between 1% and 2%. Ended up being like 2 quarts an acre for broadcast site prep. In other sites that we've done touch up on after the fact, we would use either foliar applications of triclopyr, just going by the label, or even hack and squirt applications. What seems to damage the wiregrass the most isn't so much maybe that herbicide, but the oil within the herbicide. Usually you have a surfactant or carrying agent with the triclopyr, and that seems to ding the wiregrass in our experience, not necessarily set it back, but not necessarily kill it. So the more localized treatment, the better after the fact. We also did use hexazinone to really good effect on some of our sandhill sites. Both the pellets, the proton power pellets is what they're called, and also gosh, I can't remember the trade name offhand, but it's a liquid hexazinone, Velpar L, that's what it is, using meter guns, and that's dosing individual plants. There's been a lot of research, especially around Eglin and hardwood control in sandhills, but that's a whole other I feel like webinar.
Cool. Okay, I'm just gonna keep going through these. Once established, how well do wiregrass sproutlings survive in the face of drought and competition? Well, competition. Ray, do you want to take that one?
I will take that one because we have a paper in press on competition. So competition definitely affects the plants. We do find differences in density and size when we remove competition, but these plots, I mean, they're 1 meter by 2 meter, and we're finding like 40 plants in this small little area. That's not what we would find in an intact, undegraded system. Our research has shown you find maybe 2 to 3 in a 1 meter square. So we should at most have 6. We're starting at a really high level. We're going to have high mortality, and those plants over time are going to die back. Removing competition is going to create, a higher density, but I think overall you are going to eventually want that density to decrease so that you have room for other plants within the community. One interesting thing is in plots where we did remove competition, the plants flowered in the first year. We were really surprised, even without fire. The seeds didn't germinate, so it wasn't good quality seeds, but it still produced seeds, which was pretty cool. And then we had another question on how you even mark, the plots out. After it was seeded, we put in rebar. So we have rebar 6 rebar for each plot. And so we have little subplots that are 1 meter square, and we have a frame that fits over the PVC. And then that frame is gridded. So we actually have 10 different little subplots within our larger meter square. And each of those individuals are mapped. So we can go back each year and say, did this one particular individual survive?
Yeah, great. I think that also hit on the other question about Blake's question about laying out the plots. So feel free to ask clarification if you need it. Did it seem the commercial mycorrhizae supplement was useful? I mean, I feel like if you don't have to buy it, I hope if people sell or if there are any mycorrhizal vendors on this call, I mean, chime in. In terms of our experiment, it didn't make like a huge difference. So, you know, it's kind of up to your goals, your means, your funding, you know, what the situation is. But I mean, in terms of like, would we use commercial inoculum, you know, on our restoration site? You know, it kind of goes back to what Ray said about, you know, wiregrass seedling, their natural dynamics. Once you seed, I mean, there's all kinds of things that come into play, like competition and, you know, the weather and all that kind of thing. Mycorrhizae, of course. So that's kind of one aspect of it. It's one thing that you could focus on to target to promote restoration. But you know, would we use it? I mean, probably not. We'd probably, I don't know, focus on, you know, maybe we would sow at a higher density or something if we were concerned.
You also have to consider inoculum. It's often not targeting a specific species. So in our study, we had wiregrass growing alone in its own little pot, doing its own little thing. In a big restoration area, you have your whole community. So if you're inoculating, you may actually increase competition for wiregrass because it's generally a broad general inoculum that's non-specific. So you may actually increase competition. We don't know. What I'm saying is we should probably test that in the field before trying it.
Mm-hmm. Yeah, did we see more germination in year 2 for the dry seed plots or the wet seed plots? Seems that second year germination is a strategy the plant might use in case conditions are not extremely favorable the first year. Ray, you looked at that graph most recently. Do you remember?
Yeah, I mean, I would say the biggest trend is that it's just the seed type. So we're seeing that same more fill from the wet seeds, and so we get more germination from the wet seeds, not a clear trend in whether it's wet soil, you know, or dry soil. And what I would say about the seeds is if they don't get some sort of cue for germination in the second year or the first year, then maybe they'll get that cue for germination in the second year. We don't know what that cue for germination is, whether temperatures get a little warmer and they germinate, or the light dark cycles, you know, as days get longer, that might also cue them to germinate.
Yeah. I'm going to let Chris take this next question. Yeah.
So it varied. One site we burned 6 months after, but it didn't burn. It was the windrow site. So essentially those windrows were still really sandy. They just acted as fire breaks. So the actual parts that were planted in wiregrass did not fully burn. The first actual burn on what was planted in 2016 occurred in 2019. So about 3 years. And that was that was that kind of last picture that I ended on. Very robust plants. Some of the other sites, generally it seemed like about 2 years. One site was 18 months, and that was where we planted within the take rows of the thinned pines. And this kind of touches on another question in the comment, is how was our success measured? It's a lot of it has to do with just continuity. So it's percent wiregrass covered, but we didn't actually measure it. The district didn't actually measure it. We just honestly have a difficult time going back and finding those metrics within our house, which is why we've paired up with Jen and Ray to kind of at least guide us in some of our our end goals. But generally, it feels like 2 years is a good safe bet. That 18 months didn't seem like it had deleterious effects. But I believe there was also a little bit of a function of the site prep that we did after a disturbance. So it didn't necessarily carry as intensely as other parts of that burn unit that didn't have any disturbance on it. That would more say a typical 4-year rough.
Mhm. Yeah, I know that the folks at, we had discussions with the folks at Apalachicola Bluffs and Ravines Preserve. Shout out to them for a lot of their wiregrass, restoration work in the past, their investigations, and they typically wait, about 3 years. So, yeah, I think I agree. It varies kind of depending on your goals and what you have and what the site conditions are. What type of disturbance took place at the site we collected our wiregrass from for the study? That used to be sandpine. So yeah, it wasn't great. It was very disturbed.
It had been tilled, burned. They tried to plant longleaf pine. It was not very successful. I affectionately call it the dog fennel field.
Lots of dog fennel.
Lots of dog fennel.
Our site did have active gopher tortoise burrows, and so we flagged those. Do you want to talk any more about that on the property? I mean, we just flagged them and made sure that the site preparation didn't disturb them.
Yeah, that was pretty much it. And that's kind of what we do on a lot of our other, we try and go through before timber sales too and flag out burrows, usually just making like going out about 2 feet from each corner and just making a box. And for that, the windrow excavation, we also did the same thing where we would just go through, check out the windrows and flag out around them to make sure that the operators didn't excavate through the windrow where there's a burrow.
Mm-hmm. Okay, that question. The Flatwoods coastal plain transition seems smooth for wiregrass. Anyone familiar enough with blue stem based restoration in Piedmont coastal plain ecotones? I have no experience with that. I don't know if you've chatted with anyone, Chris, who does.
I have. Yeah, it's been pretty much, most of my work has been pretty Florida centric.
Yeah.
But I like that between that comment and Chaz's comment, I think that is kind of like the next couple steps is disseminating that out to where, particularly where the office is at here, Longley Flatwoods Reserve or House Scott, where they're music to wet flatwoods that have wiregrass in them. And I'm not so sure, I'm not that familiar with Piedmont coastal plain, but
right.
I know they have very different soils than say, maybe more akin to those kind of flatwood soils.
Great question to bring maybe to the panel discussion if folks there might have some experience with that. Okay. Well, yeah, hopefully we get into flatwoods restoration. I mean, that's the that's the more tricky environment, I think, for figuring out restoration. We've done a lot in sandhills for sure. Last question, Kyle's question. Is there a germination difference between a clear-cut prep versus pine windrows?
So we did do an experiment, maybe slightly analogous to what you're asking, and we examined seed production and germination under open canopy or partial canopy. We actually have a blog post on this, but we found when there's a little more shade, and it's likely related to soil moisture and such, the plants do actually produce more filled seeds.
Did we miss anything in the chat? I think that hits on the Q&A.
Awesome. Well, thanks, Jen. I'm looking at the clock and I think we've pretty much used up the time in our hour at this point. I'm going to put up on the screen um, the email address for Ray, Jen, and Chris. And so if you have any additional questions for them, you can email them directly